In this part of the lecture, we'll learn to determine if a given function is a one-to-one function. We'll have a look at a couple of examples of this, and then we'll go on to consider the vertical line test and the horizontal line test. So let's start by revisiting the function that we considered in the previous part of the lecture. F of x is equal to 2x. You can see I've already set up my domain on the left-hand side, which goes from -2 to +2. In this case, it's a discrete domain. It contains integer values. So really we should write this down as x is greater than or equal to -2 and less than or equal to 2. And x is also an element of the set z, which is the integer. So that precisely defines our domain. In other words then, if we didn't have that list of numbers, -2, -1, 0, 1 and 2, from what I've written here, we could construct that list. And in general, it's better to write it in this algebraic form here. Let's draw the mapping diagram then. -2 is going to go to -4, -1 to -2, 0 to 0, 1 to 2, 2 to 4. This is called a one-to-one function because every individual value in the domain has a corresponding single value in the range. It's one-to-one. Now the range in this case is a subset of the list of numbers on the right, and the list of numbers on the right is called the image set. So let's just wind that back a little bit. And what we will do now is we'll keep the same domain, we'll keep the same image set, and we will just redefine our function. So instead of f of x is equal to 2x, we'll have f of x is equal to x squared. If we draw the mapping diagram for this, -2 is going to go on to 4, -1 is going to go on to 1, 0 to 0, 1 to 1, and 2 on to 4. So we should straight away see there's something different about this because we've got two values in the domain here, -2 and 2. They both map onto 4. And we've also got -1 and 1, and both of those values map onto 1. So we've got one value in the range, but there's two corresponding values in the domain, so it's not one-to-one. In fact, this is called a many-to-one function. Interestingly, though, if we just go back again, and what we'll do is we'll get rid of what we've written here, and we'll redefine our domain. Let's keep the same function, f of x is equal to x squared, but we'll say that x is greater than or equal to -2, but less than or equal to 0. And again, we'd better say that x is an integer. If we consider this as our domain, we draw our mapping diagram again, we're going to have the three values that we use, -2, -1 and 0. So let's do that. -2 is going to go to 4, -1 is going to go to 1, and 0 is going to go to 0. So by changing the domain, we can see that we've converted this function to a one-to-one function under these specific conditions. So in general, f of x is equal to x squared is not one-to-one if we consider it on the as a function of the values on the real axis. But by restricting the domain, we can turn it into a one-to-one function. Let's have a look then at a couple of interesting tests that we can do, the vertical line test and the horizontal line test. And we'll start with the vertical line test. So if we just make up some curve on this graph here, something like this. If we now draw a vertical line through this curve, let's put a line there, we can see that it cuts the curve in two places. This curve cannot be a function because the vertical line cuts it in two places. On the other hand, if we had a curve something like this, this would pass the vertical line test, because wherever we draw the vertical line, whatever value of x we choose to draw this vertical line, it's going to cut in one place. So that passes the vertical line test. It is a function. Okay, what is the horizontal line test? If we go back to our favourite function, f of x is equal to 2x. And let's just sketch that out again. F of x is equal to 2x, so we know that's going to be a nice straight line. For the purposes of the sketch, I'm assuming a continuous domain, so we get a nice straight line. If in fact we'd have used our domain that we specified on the previous slide, we would just have a set of points. We'd have one at 0, we'd have another one here, another one here, another one here. That would be the graph of our function with the discrete integer domain. So I'm just making the assumption, and to make it easy for visualization, that our domain is continuous now for this sketch. So there we have f of x is equal to 2x. That's our favourite function. What we're going to do then is we're going to apply the horizontal line test. Now, the horizontal line test is a neat way of telling us if it's a one-to-one function. We already know this has got to be a function because obviously it's going to pass the vertical line test. But is this function one-to-one? Well, yes it is, because it cuts through the graph of the function at one point. Every single one of those horizontal lines will cut it at one point. It passes the horizontal line test. It is therefore a one-to-one function. If we now take a look at the other function that we considered previously, and again we'll assume that we're working on a continuous domain just for the purposes of doing the sketch. So we'll sketch the graph of y equals x squared, and we know that's going to go something like that, isn't it? If we now start drawing on some horizontal lines, you can see straight away what's going to happen. It's going to cut in two separate places, so it's not passing the horizontal line test. It would pass the vertical line test. It's definitely a function, no question about that, but it's not passing the horizontal line test because it's cutting in two places each time. This is not a one-to-one function, it's a many-to-one function. However, as we saw before, when we changed the restriction on the domain, if we apply the same kind of restriction here, if we were to write x is greater than or equal to 0 but less than or equal to 2, and then sketch the graph of the function, it is going to pass this horizontal line test. So we can see graphically that by restricting the domain, we've converted this many-to-one function into a one-to-one function. Okay, you should now attempt the multiple choice question for this section of the lecture.